Okay. So, let's do another problem, okay? Let's look at 5x, open parentheses, 3 plus 2. In this example, distribution isn't required, okay? And I'll show you why. Do you remember this expression, PEMDAS? What does it mean? The way I learned it was, please excuse my dear Aunt Sally. Parentheses, exponent, multiplication, division, addition, subtraction. Okay? Good. So you've heard this, you remember this. So notice we have parentheses. We are going to do the work inside the parentheses before we work outside the parentheses. So what's 3 plus 2? 5. So we're going to write a new line. Okay, so we're going to write 5x, open parentheses, 5. Okay, that was just addition. Okay, and now you're really not doing distribution either, because 5x parentheses 5 close parentheses, that's the same thing as saying 5x times 5, right? Now remember the rule. When you are multiplying a variable that has a leading coefficient, okay, that's what this is called. This is called a leading coefficient. I'm going to write it Leading coefficient, coefficient, ICIENT. I think I got that. Coefficient. Yeah. That's the 5. Okay. So when you hear me say the coefficient, what I'm saying is the number to the left of the letter. So you have a variable, x, with a leading coefficient, 5, multiplied by this number. This number, 5, right here, has its own name, and that name is constant. Okay? So this is called a constant. So let's go through it again. And just want to label the x is called the variable. V-A-R-I-A-B-L-E, variable. So we have a variable with a leading coefficient multiplied by a constant. What we do here is we multiply the leading coefficient times the constant and just stick the variable on the end. So what is the leading coefficient times the constant in this case? Correct. And we're trying to use the academic mathematical language. But basically it's 5 times 5 with an x after it. So that's 25x. How could we check if we're right? The same thing we did before. In other words, take this initial expression, set it equal to what we think is the simplified expression. So let's write out 5x, open parentheses, 3 plus 2, close parentheses, equals 25x. So this is our check. Well, 3 plus 2 is 5. So we have 5x, open parentheses, 5, close parentheses, equals 25x. What was that? Do you remember that word I used when I said stick a number in for x? It's maybe I didn't use it. It's substitution. So substitute a number for x. I like 0, 1, or 2. Okay, those are really easy. Let's try 0. 5 times 0 is 0. 0 times 5 is 0. 25 times 0 is 0. So 0 equals 0. Let's check another one, because sometimes 0 can be a little misleading. Let's try 1. 5 times 1 is? 5 times 5 is? 25 times 1 is? So 25 equals 25? That's still true? Let's try 2, and then we'll be done. 5 times 2 is? 10. 10 times 5? 50. What about 25 times 2? 50. So 50. As long as that equivalent stays, then this is a true, you've done correct work, and you've justified your solution. And only at that point can you put around 25x what one of my former students calls the red box of correctness. Please, yeah, just when your final answer, put your box around your final answer. Okay, let's do it. Let's do more. Can I erase all this? All right. Let's do something that requires more than just one simple thing. Let me think of this for a minute. Let's do 6. All right, there's our problem. And what we're being asked to do in this problem is to simplify. And the cruel joke is simplifying is always harder than solving. There's no equal sign up here, so you're not trying to find out what x is. So I spy a number sitting by itself to the left of an open parentheses. Immediately, I'm thinking of a certain property that starts with a D. The distributive property. So I like to make what's these called distribution lines. This helps a lot of students. We draw the lines to point to where we're going to multiply out by. If you look inside the parentheses, we can't combine a variable with a constant. They are like oil and water. They're unmixable. But we can multiply 6 times x and 6 times 9. What is 6 times x? Just 6x. How about 6 times 9? 54. Just bring the rest of this expression down. Plus 3x minus 4. Now, so the property we use to do this is the distributive property. We can call it distprop. Okay, now, we need to do something that we abbreviate CLT. And what that means is combine like terms. So first we have to identify which terms are like, okay? The 6x and the 3x with its sign are like one another. They're both examples of that variable with leading coefficient. Can you guys say that out loud with me? Variable with leading coefficient. Variable with leading coefficient. Okay, singular. Okay, now, so when we see these two, it's like, oh, okay, these are like animals of the same species. Okay, they can combine. So let's do that. What is 6x plus 3x? Remember, just add the leading coefficient, put the x. What? 9x. Okay. So so down here, these combine together to give you 6x plus 3x. Well, you know what? Let's write it out. We'll write it all out. 6x plus 3x. And then we'll write another line. Plus 54 minus 4. And I hope it goes without saying, but maybe it needs to be said, that 54 and negative 4 are also like terms. So positive 54, this guy's gone, positive 54 and negative 4 are both constants. So they combine together here. All right? So here we just rearrange the terms. Now we're going to do the combination. You told me 6x plus 3x is 9x. Okay, good. What is positive 54 minus 4? 50. So we just put plus 50. That looks right. But we're going to check it, okay? So we're going to check it by rewriting the original, and I'll just put it equal to the answer. You rewrite the original up. Might be going off screen if I do that. So I'll just write it again. 6, open parentheses, x plus 9, close parentheses, plus 3x minus 4 equals 9x plus 50. And really, this equals sign has a question mark above it, because we're kind of asking the question, does the left side equal the right side? Well, let's plug in 1 for x and see if it does. So I'm just going to plug in a 1 everywhere I see an x. 1 plus 9 is 10. 10 times 6 is 60. 3 times 1 is 3. 60 plus 3 is 63. Are we with me so far? Do you agree with me so far? 63 minus 4, 59. Is that right? Is 63 minus 4 59? Good. So we think the left side, if x equals 1, we think the left side would be 59. What's 9 times 1? What's 9 plus 50? Nice. So we proved it. Okay, 59 equals 59. So what do you think about this? Is this easy? Let's try it with fractions. So we'll do one more. We'll try it with fractions. And we'll see where we get. This will be our last problem. 1 over 3, open parentheses, 6x minus 4, close parentheses, plus 9 fifths x plus 7. And once again, you're asked to simplify. So the presence of fractions doesn't change anything about your thought, because this is just a number. It's sitting to the left of a parenthesis, so we're going to distribute the 1/3 to each of the terms inside the parentheses. Looking at the terms inside the parentheses, we see they are dissimilar. Okay, variable with a leading coefficient and a constant. They can't be next together, so we're just going to distribute. And we're going to write it all out before we do it. We're going to write out what we're going to do. 1/3 times 6x plus 1/3 times -4 plus 9 fifths x plus 7. These are my favorite problems. So everywhere we see a whole number, it doesn't matter if it's a leading coefficient of a variable or if it's out by itself. Everywhere we see a whole number where we're going to end up multiplying, we're going to write that whole number over 1. Okay, so instead of 6, we're going to write 6 over 1. Instead of -4, we're going to write -4 over 1. We'll leave the 7 for now. We'll come to him later. So we're just going to write a new line. 1/3 times 6 over 1x plus 1/3 times -4 over 1 plus 9 over 5x plus 7. So far, so good? Well, remember, when you're multiplying fractions, you multiply across the top and across the bottom. So that's our next step. One times 6 is 6. 3 times 1 is 3. So we have 6 over 3x plus 1 times -4 is -4. 3 times 1 is 3. So we have -4 over 3 plus 9 over 5x plus 7. It is tempting, but wrong, to try to combine 6/3 x and -4/3 because they're dissimilar. This is the leading coefficient of a variable, and this is a constant. Can we simplify 6/3? What is it? 2. So we can write 2x. And then here I have something that could be confusing. I wrote plus a negative number. I like to write it that way. This keeps it very clear in my mind that this negative goes with this fraction. So I'm going to continue to do that. 2x plus -4 over 3 plus 9 over 5x plus 7. Okay. Do we have any like terms? We have two pairs of like terms. We've got the 2x, and that's like the positive 9/5 x, because they are both examples of a variable with a leading coefficient. Doesn't matter if the leading coefficient's a fraction or a whole number. So we'll combine those together. And then over here I've got -4 over 3. That's a constant. And I have 7, which is a constant. I can combine constants. Okay. Those will go here. So let's write out what we're going to do. We've got 2x plus 9 over 5x plus -4/3 x, or sorry, -4/3, not x, plus 7. But I have a problem now. My problem is I can't just add 2 to 9/5, and I can't just add -4/3 to 7. So what I need to do next is I need to write the 2 as a fraction with 5 in its denominator, and I need to write the 7 as a fraction with 3 in its denominator. So over in side work, I'm going to show you how to do that. You need to have side work on your page. This is the side work. So here's how you do that. You multiply 2 over 1 times 5 over 5, and that's going to equal 10 over 5. Because 10 over 5 reduces back down to 2, then these are equivalent. And we can go in here, and instead of writing 2x plus 9/5 x, we can write 10 over 5x plus 9/5 x. Well, this is beautiful because now we have common denominators, and that means we can just add the numerators together. It's going to be great. Okay, next, the 7. We need it with the 3. So I'm going to write 7 over 1 times 3 over 3. And that's going to equal 21 over 3. Again, reduce this down to 7. So it's legit. And we'll just put plus -4/3 plus 21 over 3. Well, now it's just a matter of adding together the numerators. What's 10 plus 9? 19. So 10/5 plus 9/5 is 19/5. That's an irreducible fraction. 19/5 x. And now I need to do -4 plus 21. What's that? -4 plus 21. Is it 17? Okay, so -4/3 plus 21/3 is 17/3. 7 plus 4 is 11, so 17 plus 4. Yeah, so we'll write plus 17/3. Now that is the simplified fraction, okay? We're going to do a real simple technique here to check by using a 0 and see what we get to make sure we got it right. If this is 0 up here, then 6 times 0 is 0. This is -4, okay? -4 times 1/3 is -4/3. You with me? So far we're at -4/3. This is 0, so 9/5 times x is 0. So we just need to add 7. 7 is 21 over 3, so -4/3 plus 21 over 3 equals 17 over 3. You see how quickly we got that? Come down here, plug in a 0 for the x. 19/5 times 0 is 0, leaving us with just 17 over 3. We did it right, okay? Always check. Okay, well guys, that is what I wanted to show you how to do today. And now I'm going to give you an assignment. So for my home-based learners, you'll see this pop up on Google Classroom. For the rest of you, I'm about to release it in person. Thank you so much for watching. Please make sure to like and subscribe, hit that notification bell so you're always alerted to new videos in the future. Thank you.